Hello friends, welcome to my channel. This is our today's question on LeetCode, and this question is basically daily challenge on 18th August, and the question is maximum network rank. So we will read the question first and we'll try to figure out how we can solve this question. So there is infrastructure of n cities with some numbers of road connecting these cities. Okay, so we are having an infrastructure of n cities which are connected with some roads. Okay, and each roads of I is equal to ai comma bi indicates that there is a bidirectional road between cities ai and bi. So basically you can see that we are having an integer n and we are having an two-dimensional vector integer vector roads. Okay, and in this vector the first element, okay, for each element the first member is going to be ai city and the second member is going to be another city bi. Okay, and what does it mean? It means that there is a road which is connecting ai and bi, cities ai and bi, in bi-directional way. Okay, so there is a bi-directional road between ai and bi. So this is the meaning of roads of I. Okay, the network rank of two cities is defined as the total number of directly connected roads to either of cities. So basically network rank means of two different city, means that let's say we are having cities 0 and 1. So you can see that this is our infrastructure. Okay, it is a graph basically. So if we are talking about 0 1, so this is a pair of two cities. So basically for this pair the network rank is defined as, or is defined as total number of directly connected roads to either cities. So basically total number of roads which is directly connecting these cities 0 and 1. So you can count it. So this is one road. Okay, so this is a particular road, so this is again a particular road, this is again a particular road, and this is again a road. So basically you can see that there are four rows which is directly connecting 0 and 1, which is directly connecting cities 0 and 1. So for cities 1 and 3 you can also see that there are four roads. So basically this one is a particular road which is connecting 1, this road is connecting 3, this road is connecting both 1 and 3, and this road is connecting 1. So you can see that for 1 and 3 our network will be nothing but 4. Basically our network rank will be nothing but 4. So in this way they are calculating network rank. And after that what they have given, if okay, if the road is directly connected to both cities it is counted once. Okay, so we have done in the same way that 0 and 1 is connected by a road, so we will count this road once only. Okay, so yeah, the maximal network rank of the infrastructure is the maximum network rank of all pair of different cities. So basically what we have to do, they have given us a definition, another term, maximal network rank, which is nothing but maximum network rank of all pairs of different cities. So basically we have to iterate over all pairs of cities, and what we have to do, we have to find out maximal network rank of the entire infrastructure. So basically what they are asking, we have to take pair of all cities, let's say 0 1 or 1 2 or 1 3 or 0 3 or 0 2, and corresponding to all pairs we have to find out what, we have to first find out network rank of all cities, all pairs, and we have to maximize the value. Okay, so we have to return the maximum value of network rank. So basically let us think about how we can solve. So basically we will have pairs. So let's say for pair 0 and 1, you can see that there are the network rank is nothing but 4. For 0 and 3 you can see that the network rank is nothing but 1 2 and 3. So basically these three roads are directly connected, this one, okay, this one and this one, these three roads are directly connecting them. So network rank is nothing but 3. And talking about 1 and 2, so for 1 and 2 our answer will be nothing but 1 2 3, so it will again 3 and so on. So basically for this particular infrastructure you will find that the maximum will be nothing but 4. So max network rank is 4. So basically what we will do, we will just return this value 4. Okay, so we have to do this thing. So let us think about how we can solve this question. So basically what we can do, we can have a adjacency list. Okay, and we will so basically what we will do, we will have a adjacency list. So we will have an adjacency list. Okay, so basically for 0 what we will have 1 and 3, and for 1 we will have 0 1 and 3, 0 1 and sorry 0 2 and 3. For 2 we will have 1 only, and for 3 we will have 0 and 1. Okay, so basically you can find out from this you can see that this 0 is connected to two cities, that is 1 and 3. Okay, 1 is connected to three cities, that is 0 1 and 2, and 2 is connected with only one city, that is 1, and 3 is connected to only one two cities, 0 and 1. So basically we will have this adjacency list, and from this adjacency list we will find out to how many cities the particular city is connected. So we can directly get the size, so in order to find out how many cities are connected to a particular cities. And what we will do, uh, for each road, or you can say that 0 and 1 is connected, so this road has to be counted once. So basically what we can do, uh, we can use map here. So what we will do, we will have a map of pair of integer and integer, and again integer, let's say MP. So we will have this map. Okay, and this map will store the particular road. So basically this map will check whether there is any direct road between two cities or not. So basically we will have this map, and what we will do, we will just iterate over all pairs. So we will iterate over all pairs. Okay, and what we will do, we will have two cases with us. So basically if there is road between two cities, okay, and the another condition is that no direct road. Okay, so in both case we will try to find out. So for this case, if there is no road between there is road between two cities, so what we will do, we will just find out the value of what we will do, we will just find out to how many cities these two cities are connected. So basically what we will do, we will so basically let's say cities are A and B. So cities are A and B. So what we will do, we will just count how many cities are directly connected to A plus cities directly connected to B. And you can see that here we are counting one case more, that is A and B are counted twice. So basically we have to reduce one here. Okay, so we have to reduce one because A and B is counted twice. So since A and B has been counted twice, so we have to reduce one here. And if there is no direct road, what we will do, we will just find out the sum of these two values. So basically how many cities are directly connected to A and how many cities are directly connected to B. So basically we will just find out this, and we will this will be the rank for this pair. Okay, so in this way we will find network rank. Okay, so in this way network rank of for each pair will be find out. And what we will do, we will just for maximizing it, we will just have a variable and we will try to maximize it. So let us try to code this question. So basically we will have a adjacency list, so vector of int adj, and the size will be nothing but n. So basically it is adjacency list. Okay, and we will iterate over all the roads. So for auto ELE of roads, and what we will do, for we will just create this adjacency list. So basically adj of ELE dot 0 ELE of 0 dot push back ELE of 1, and vice versa also, because the road is bidirectional, okay, ELE of 0. Okay, again we will have a map here. So basically map of pair of integer and integer and again integer. So this will store, this will check whether there is a road or not, there is a direct road between two cities or not. So basically if we are iterating over road, so we can say that there is a direct road between these two cities, 0 and ELE of 0 and ELE of 1. So basically what we'll do, we will just write a map of ELE of 0 and ELE of 1 as 1. Also we have to write map of ELE of 1 and ELE of 0 as 1, because this is a bidirectional road. So we have to write for ELE 0 and ELE 1 also, and ELE 1 and ELE 0 also. So basically these are two different pairs. So for these two different pairs we will have a road. Okay, 0 1 is also a particular pair and 1 0 is also a particular pair. So basically we are having roads for both the pairs, so that's why we have to write for both pairs separately. Okay, so in this way we have created our adjacency list, and we have stored whether two cities are connected with maps or not. And after that what we will do, we will just iterate over all pairs. So for this we will iterate from int I is equal to 0, I less than n minus 1 and I plus plus, and again we will have another loop. So for int I is equal to j is equal to I plus 1, j less than n and j plus plus. So basically here we are having two cases. If there is direct road between I and j. Okay, so basically what we will do for this case, okay, so we will have a path. So int paths, or let's say network. So network will be nothing but adjacency adj of I dot size plus adj of j dot size. So basically this part we have discussed here, that if there is no direct road, we will just directly count the size. Okay, and here we will make another condition. So I will write like this. So we will make condition here, if there is a direct road. So basically what does it mean? If mp of I and j is equal to 1, so what we will do, we will just reduce the value of network by 1. So network minus minus. So I will write here, we have done this in order, or what I can write, we have, why we have done here. So because we have done this as we have recounted pair I and j. So for this we have to reduce the value of network, and we have to maximize it. So for maximizing it, I will take a variable maxi, which will be 0. So what is the meaning of this variable? So this will return maximal network rank. Okay, so here we will maximize it, and maxi is equal to maximum of maxi and network. Okay, and finally what we will do, we will just return maxi. So let us see whether the code works or not. So you can see that both the test cases are passing. So let us see for main cases. So I don't know why it is taking time. I think there is some kind of network issue. Hmm. So why, I don't know why it is taking time, so let us try again. So I will try to refresh this page. So yeah, let us see again for the main cases. So you can see that all the main cases are also passing. So I will try to explain this code again. So basically what we are doing, we are just counting to how many cities each cities are connected. So 0 is connected with these two cities, that is 1 and 3. 1 is connected with these three cities, 0, 2 and 3, and 2 is connected with one city, that is 1, and 3 is connected to only two cities, that is 0 and 1. And what we have done, we have a map. Okay, so this map will check whether there is a direct road between two cities or not. Okay, so we will store these values and we will iterate over all the pairs of two cities. And if these two cities are connected, directly connected, so basically what we will do, we will just count the total number of cities that is connected to city A plus total number of cities which is directly connected to B minus 1, because A and B are counted twice. And if there is no such a road between A and B, so for this case what we will do, we will just not reduce minus 1, we will not reduce my 1 here, and finally we will maximize this. So that's what we have done here. I have taken an adjacency list here. Okay, and I have stored the value in this adjacency list, and again for I have used map here. And since the road is bidirectional, we have to store these value for both the pairs, that is ELE of 0 and ELE of 1, and ELE of 1 and ELE of 0. For both the pairs we have to store the value, and after that what we will do, we will just iterate over all these pairs. And if there is a road, we have to reduce the value of network by 1, and otherwise we will not reduce the value of network. And network is nothing but it is sum of adj of I dot size plus adj of j dot size. Basically it is sum of total number of cities directly connected to city I and city j. And that's what we have done here, and we have maximized the value of maxi, and finally we have written it. So I hope you understood my solution, and if you like my solution, if you like my code, you can like my video also. And if you have any kind of doubt regarding this question, or you want to share any other idea regarding this question, you can write in comment section. If you want to see some more videos like this, you can subscribe my channel, and the code link will be present in description. Thank you.